If I went back here to plain old y equals x squared and say I added a 3 on this one like we had just done over there, if I threw a 3 in front of this x squared, actually I probably should, since these people need this for notes, I better take that off. Go away. If I made it y equals 3x squared, how do you make that 3 impact your graph? What does it change? Because most of the time you're going to graph 1, 1, 2, 4, 3, 9. You're going to know those numbers in your sleep. You're going to graph them so much. The 3, well actually just do it with the numbers. If you sub 1 in for x, what do you get? 3. So instead of getting 1, 1, you'll get 1, 3. And if you sub 2 in for x, 2 squared is 4, but then you have to multiply it by 3. So it's going to make that 4 become a 12. And it's going to make the 9 become, you're taking it times 3, so it makes the y coordinate, that and the y coordinate become 27. So what you're going to do, if you have a number in front, you're going to take all your y coordinates times that number. It's going to change your y coordinates every time. It never changes the x's. Never, never, never change the x's. If there's a number out front, you just change the y coordinates. Multiply it by whatever that number is. Okay. He's excited about something over there. So let's go see if we can kind of list this. What you've just seen, I showed you standard form of a parabola, but what we've actually worked with here in order to make our graph shift left, right, up, and down, it's called vertex form because you can easily find the vertex when you're given that form. And as a formula, vertex form looks like this. And math and science people just love formulas. So we're going to look at how you find the various parts once you're given an equation in that form. So if I'm in vertex form here, and I want to find the coordinates of the vertex is going to be wherever it shifts to. So that this has an x minus h in the quantity, where's that going to make it shift? Would you guys say which direction do you go if it's in the quantity? You go left or right, and you go opposite the sign. So it's going to go right h. So it means your vertex is going to be at h over. If that's x minus 2, it's going to be a 2. If that's x minus 5, it's going to be a 5. Okay, your y coordinate is how much you shifted up or down. How much is this one going to shift? Up k, whatever number that is on the end. So your vertex is going to end up at h and k. And I'll do this with numbers in a minute. In fact, let's do it with numbers now so we get the comparison. So suppose I gave you negative 3 times x plus 7 squared minus 4. And I said, tell me where the vertex is. So, because the x plus 7 is going to make me go left 7, it's going to go opposite. The y coordinate's going to stay the same, so you're going to be at negative 7, negative 4. That's where the vertex will be. That's where your origin will be. That's where you'll count from. Okay, then I'm going to ask you some other things. I'm going to ask you what direction will it go in. How do you know whether this parabola is going to curve up or curve down? Yeah, the sign in front. So when we talk direction, we know if this number up front, which is A, if A, I should write this way. If you have a positive A, it goes up. If you have a negative A, it goes down.
Does it matter what the number is there?
Nope, the number has no effect on the direction. The number affects how wide it is, and I'm going to get to that in a second. Okay, so in our case, on this one, which direction will this one go? If it's got a negative 3, it's going to go down. It's a negative. So we know this parabola will curve downward. Okay, then they're going to ask you for the line of symmetry. What did I just tell you about the line of symmetry back there on that other page. It's that vertical line, so it's always going to, vertical lines are always x equals, and it has to equal whatever the x coordinate of the vertex is. So, in this case, in formula form, the x coordinate of the vertex is h in the general form, so we'll say x equals h. Over here, what's it going to be? It's going to be x equals x coordinate is -7, so that's where the line of symmetry is going to be a vertical line for -7. You must write the x equals. It's not a line if you don't write the x equals. So, and that really pains people because come test time, that's a whole point on every problem if you don't write x equals. So that's important. And then lastly, the width. How wide will this thing be? Well, when we put the 3 on it, did it get wide or narrow? When we put the 3 on it on the graph, it got narrow. So if your A value, not whether it's positive or negative, that's why I'm putting absolute value on this, because I don't care if it's positive or negative. If the number A itself is bigger than 1, it's going to be narrow. Okay. If A actually equals 1, that's normal. And then what happened when we put a fraction on it? Something between 0 and 1. That made it wide. So on this particular problem we were looking at, it's got a 3. The negative doesn't matter, it's a 3. So is it going to be wide, normal, or narrow? Since 3 is a number bigger than 1, forget the negative. 3 is a number bigger than 1, yep, it's going to be narrow. On the top section of your worksheet, the first 6, that's all you're supposed to do, is just list those 4 things. You don't have to draw the graphs of them. Just list the vertex, direction, line of symmetry, and the width. Okay. The bottom 4 on that worksheet, you actually are going to graph. So we're going to graph another 1 or 2 by hand to make sure you've got it. I picked the wrong one. Oh, hold it. You guys need graph paper, don't you? Okay, so I want to graph this lovely y equals 1/2 times x minus 4 quantity squared minus 1. We look at it, we see the square, and we go instantly, the shape is going to be shape. If it's just, I just want to know in general, if it's got a square on it, it's going to be a what? A parabola. Guaranteed. If it's got 1 x squared in it, it's just x squared to the highest power, it's going to be a parabola. It won't be anything else ever. So then, you're going to go, okay, where is the vertex going to be? Where is this baby going to shift? If it's x minus 4, which way is it going to go? It's going to go right 4, so it's going to be at 4. And is it going to be up 1 or down 1? Down 1. Change the sign on the first one, don't change it on the second one. So if you're actually plotting this, you're going to go find 4, -1. That's your new origin, and that is where the vertex of your parabola is going to be sitting, 4 over 1 down. Okay, is this one going to go up or down? Based on which number? Whether it's positive or negative in front. So you're looking at that coefficient number out front. It's a positive 1/2, so you're going up. Okay. The line of symmetry, how is it always written? X equals whatever x coordinate you're going through. What x coordinate are you going through? 4. And then lastly, how wide will it be? It's a half. It's a fraction. Fractions make it get wide. Numbers larger than 1 make it get narrow. Wide. Wide. But you need to actually plot some coordinates. You got to plot it exactly, not just kind of slap a little U-shaped curve in there somewhere. So you will need to plot a few points, not many. On most of these, you should be able to do 0, 1, 2, 3. Okay. What were the standard y coordinates if it was just plain old? We've already done the shifting, so all you're thinking about here is, if I was just going to graph x squared, what would my y coordinates be? 0 squared is 0, 1. Yeah, 1, 4, 9 are going to become your friends. You're going to count 1, 4, 9 boxes so many times you're going to go to sleep. It's going to be automatic 1, 4, 9. Just like counting boxes of slope with parabolas, 1, 4, 9, over and over. Now, in our case, though, I added a wrinkle. What else do I have to worry about that might change those coordinates? What made me have to change these y coordinates to 3, 12, and 27? The 3 in front. So if you have a number out front, we have 1/2. What do I have to do to all those y coordinates? Yeah, times them all by 1/2. Yeah. So that's going to make them, 0 is going to, of course, stay 0, but then you're going to have a half. Half of 4 is 2. Half of 9 is 4 1/2. So those are actually the points you're going to plot then. You can take them all times half. So then go to your new origin where your vertex is at, and from that point you're going 1 over and a half up. And it's the next point 2, 2. From that original vertex, where our origin is, 2 over, 2 up on both sides. And then I have to go 3 over, from that point over 3, up 4 1/2 on both sides. Is it still a U-shaped curve? Yeah. Is it as skinny as the last one? No, it got wider because it got the half on it. And so you need to connect the dots and just run it up off the edges of the graph paper, or in your case, off the edge of one square. Is that horrible? It's not bad. Okay. So that's the basic graph. I want to do one other one, not because this is actually an easy one, but everybody makes this hard. So I have to make sure you know what to do if you see this. What if I gave you negative 2/3? Should I really do 2/3? Yeah, we'll live with it. Ooh, not -5, +5, sorry. What strikes you as weird about how that looks? There's no, yeah, and it's not quantity squared. Yeah. If there's no quantity squared, then that means, did you shift sideways? No, it just means you didn't shift. So your x-coordinate of your vertex is still 0. I have all kinds of people who freak out over this because if it's not quantity squared, it doesn't look right. You just go, oh, okay, well, then that means my vertex, my x-coordinate's at 0. It didn't move anywhere. Now the +5 means I went where? Up 5. So my vertex is at 0, 5. That's all it is. Okay, tell me about the direction, up or down? Direction would be down because it's negative. And then I need to know the line of symmetry. You have to write me more than 0. X equals 0 because it's a vertical line. And lastly, what kind of width are we going to get on this one? I didn't need to do a fraction again. I want to change that because I want to prove a point. Let's graph. What would still stay on? Oh, let's just do -2. So now is it still going to be wide? Now that it's 2, it's going to be narrow because we just did a wide one. I want to do a narrow one. What can you plot right now? We know the vertex is at 0, 5 because you know this thing went over 0, up 5. So you're starting up here. That's going to be the vertex. You all told me this baby is going to come down from there, but I need the actual points to plot. So what are the normal numbers you put in your t-table? 0, 1, 2, 3, and 1, 4, 9. Just square them all. Then you need to go back and do what? Times them by the number out front, which actually it's -2, so you're actually going to be taking them all to the -2, which means I'm going to get -2, -8, -18, which we may or may not plot. I think we'll run out of boxes before we can get to 18. So if you don't have enough boxes, don't plot it. So this says I have to go 1 over and 2 down from where? From the vertex. 1 over 2 down. 2 over and 8 down. So from that vertex, 2 over, 8 down. 2, 4, 6, 8 on both sides. And I know I don't have enough boxes to go 18 down. Oh, shoot. I'm making another change. I forgot they added these in there. Instead of an equal sign, what if I change that to a less than? You would have to shade, and you'd also have to watch for dotted and solid. Which one would it be? Yeah, it can't equal. It's not equal to, so it's not going to be solid. So, yeah, we would be the dotted line coming down through here. And then you would have to shade it. These are always going to be y is greater than or y is less than. So if it's saying y is less than, where would be all the y coordinates that are less than that? Yeah, shouldn't they be? They should be I would pick the vertex. Where's less than the vertex? Down below, so we're shading in everything on the inside of the parabola. If it had been greater than, you'd have been shading everything outside the parabola. You're either going to be inside or outside. I would go from the vertex. That's the easiest place. If it was greater than from the vertex, greater than would be up. So I would be going up. I'd actually go from any point on the parabola, I would be going up, which makes it all outside. It would be all over here. Now, if it was, if this one top one up here, the first one we did had been less than, that would be below the vertex. It would be everything, any point on here, it would be below it. So it would be everything on the outside. So you're either inside or you're outside when you shade. Isn't that amazing? Okay. Now, you guys get to be my guinea pigs. I've never done this before. Oops, we're stopping.